Hi, Namaste. I am Tippeswamy MS. In this class, I am going to speak on one of the most important property of the star, that is brightness. I hope students will get idea how the astronomer measures the brightness of the star till end of this class. Dear students, look at this small picture. This is arranged as you look at in the night sky. This is the one of the topmost brightest star which is present in the night sky, that is Sirius, which is present in the Canis Major constellation, which is almost 8.6 light year away from the Earth. Another two known stars which are present in the Orion constellation, one is in this position, one is Betelgeuse. This is the second brightest star in the night sky. This is the another Regal. This is the position of the Regal in the Orion constellations. Dear students, there are many known stars, known brightest star present in the night sky. This is the Procyon, Pollux, Gemini, Aldebaran. We know that stars' brightness is differ from one another. Let me know how the brightness of the stars measured by the astronomer. The brightness of the stars measured by the astronomer using a magnitude scale. The word magnitude refers to the celestial object's apparent brightness or apparent visual magnitude. Therefore, astronomers measures the brightness of the star using a magnitude scale. Initially, we go through the apparent magnitude. The apparent magnitude helps, which is the measures the brightness of the star. So, the brightness of the stars are precisely explained with the magnitude system. Here, the brightness of the star that appears to us is called as apparent brightness. The apparent brightness of any star which is depends on actual distance as well as its luminosity. You know, this is one, as you said in the last slide, Sirius is the one of the topmost brightest star in the night sky, which is almost 8.6 light year away from the Earth. Another one is second brightest star, which is the Betelgeuse, which is 645 light year away from the Earth. As the distance varies between these two stars, obviously brightness is varies. Brightness of the star is varies. The magnitude based on the apparent brightness, the magnitude based on the apparent brightness of the star is called as apparent magnitude. Here, the apparent magnitude, which is mainly based on the apparent brightness, how this is the star appears to us from the Earth, is called as the apparent brightness. That is we call as, so the magnitude based on the apparent brightness of the star is called as the apparent magnitude. And is also apparent magnitude of the star, which is equal to the star's flux. Star's flux received by us. That means the amount of energy reaches the detector per square centimeter area. That means instrument which is going to detect the star's energy. Initially, around 150 BC, a great astronomer Hipparchus classified the naked eye star into 6 groups of different magnitude, that means different brightness. Here, what he did, the brightest stars kept in a first magnitude. This is the first magnitude, which is the contains brightest stars. The next brightest star, which is contains the second one, third one, next fourth one, next fifth one. The sixth magnitude class, which is contains almost dimmest stars. So here, Hipparchus classified the stars into 6 groups. In 1856, what is N.R. Faxon, another astronomer, taking the ratio of the brightness of the first group and sixth group as a 100:1. That means The ratio of the brightness of the first and sixth group stars is 100. That means the whatever the star contains in the first magnitude class, which is almost 100 times brighter than the sixth magnitude scale. And also assume that equal brightness of two stars gives equal magnitude. Let's consider L1 and L6 are the apparent brightness of the two stars corresponding to the first and sixth magnitude scale. So the ratio of those two brightness of those two stars is equal to 100. L1 is the apparent brightness of the star which is contains in the first magnitude scale. L6 is the apparent brightness of the star which is having the sixth magnitude scale. Therefore, ratio of these two brightness of these two stars which is equal to 100 according to N.R. Faxon. Therefore, what he assumed that ratio of the brightness of the any two stars gives equal difference in magnitude. Therefore, ratio of the L1 by L2, L2 by L3, this is the ratio of the brightness of these two groups of stars. L1 which is the star which is contains in the first magnitude scale, L2 is the apparent brightness of the star which is contains in the second magnitude scale. This is we consider the brightness ratio of the brightness is equal to x. This is x, this is x, this is x, this is x. Therefore, L1 by L6 that is equal to x to the power of 5, that is equal to 100. So we have x is equal to fifth root of 100 which is gives 2.512. 2.512 it is the factor ratio of the brightness of the each step of each successive magnitude scale. That means first the number 2.512 which is tells the first magnitude stars are 2.512 times brighter than the second magnitude star. It means the first magnitude stars which are brighter than the second magnitude stars. The first group of stars which are contains more bright, second group of stars in the next bright of star. So here third magnitude stars which are dimmer than the second 2.512 times of second magnitude scale system. Like this, therefore, each fact, this is the number or a factor which is tells the ratio of the brightness of the first, second and third and fourth and fifth and sixth. Therefore, ultimately we have what is the magnitude of the brightness difference in the first magnitude and sixth magnitude scale system, which is equal to multiplication 2.512 raised to 5, that is equal to 100. If Lm and Ln are the brightness of the two stars having apparent magnitude m and n, we know that brightness of the star that appears to us is called as a apparent brightness. Ratio of these two star brightness which is equal to what we learned in the last slide, the ratio of the first and second magnitude stars which is almost equal to the 2.512. Therefore, ratio of these two brightness which is equal to the 2.512 factor rise the difference in the magnitude. This is a very important difference in the magnitude. The ratio of the brightness of the any two star which is equal to the 2.512 to the power of difference in their magnitude. Apply the log both sides. This is therefore log m by log n, which is log 2.5 is equal to 0.4 n minus m. N minus m are the apparent magnitude. The difference in the apparent magnitude which is equal to 2.5 log Lm by Ln. According to this equation, the stars having higher in magnitude, lesser in brightness, and vice versa. Let's see some examples using a magnitude scale. This magnitude scale contains both positive and a negative number. These are the negative number, this is the positive number. The stars having higher in magnitude, those stars as called as a dimmer stars. The stars as a lesser in magnitude, those stars appears as a brightest stars. See here, what are the stars which are present at the having the zero magnitude scale system? Those stars are the highest brightness in the 6th magnitude scale system. Here, the difference in magnitude is very important. The N and M are the operant magnitude. The difference in magnitude we call as a delta M. If the difference in magnitude is 1, the operant brightness, the ratio of the brightness which is equal to 2.512. The difference in magnitude 2, the ratio of the brightness 2.512, almost 6.25. The ratio of the brightness is the difference in the brightness is 3, which is equal to almost 16 times ratio of the brightness is difference. See here, the ratio of the brightness or the difference in the operant magnitude is equal to 5. The ratio of the brightness is 100. Let's do some calculations. Consider a star A which is having a operant magnitude is a +2. The star B which is having the operant magnitude +4. The difference in the magnitude is 2. Therefore, the star A is 6.3 times brighter than the star B. Suppose if we consider a star, another star present at the 0 magnitude scale. A star present in the 3rd magnitude scale. The difference in these two magnitude is 3. Therefore, what is the star present at the 0 magnitude, which is equal to almost 16 times brighter than the magnitude of the star which is present in the 3rd magnitude. See, Sirius is the topmost brightest star in the night sky, having the operant magnitude which is a -1.4. Let's see the -1.4, which is almost comes here. Therefore, compared to this positive higher magnitude stars, the Sirius is the highest brightest. What is the Sirius? Is how the brightness of the Betelgeuse compared to this star, which is equal to difference is that is plus 0.58 minus of minus 1.4, which is almost equal to the 2. Therefore, Sirius is the 2 times brighter than the Betelgeuse. So, let another Sun is the topmost brightest star in the magnitude scale system, that is a -26.7, which is equal to far away from this negative this one. Venus is the one of the brightest planet in our solar system, having the operant magnitude is a -4.4. The full moon, the operant brightness is a -12.6. This one large Hubble space telescope stars having a operant magnitude is a +30. Here see the several stars in and around the constellation of Orion. Here see what I said, this is the Betelgeuse super red giant star having the operant magnitude is a +0.45. Compared to the Sirius is the -1.44, because this is the positive higher in magnitude, this is the negative lower in magnitude. We are conclude that Sirius is the brightest star compared to the Betelgeuse. Similarly, Rigel is the again higher in magnitude, positive +1.5. Sirius is the -1.44. Sirius is the again brightest star than the Rigel. Dear students, as we know that the apparent brightness of the star, which is mainly depends on the actual distance and their luminosity. Here the star distance vary considerably. The star distance vary considerably. So the apparent magnitude which is not help to measure the actual brightness. If we choose an actual distance of the star, that is that actual distance helps to measure the luminosity, that means actual brightness. Therefore astronomers, they have chosen a standard distance of a star, that is a 10 parsec. If a star A present at a standard distance 10 parsec, then its magnitude we call as a absolute magnitude. That means absolute magnitude m of a star is defined as its apparent magnitude would be it were placed at a standard distance 10 parsec. For that, consider we have a star of m, it is the apparent magnitude. That star having a brightness, apparent brightness Lm, and at a distance from the earth is d. Another star we consider the absolute magnitude, that is m, and its brightness Lm, and the distance from the earth is called as a standard distance, that is capital D, that is a 10 parsec. Therefore difference in their magnitude, that is equal to 2 logarithmic ratio of their brightness. As we know that by the inverse square law, intensity receiving by the earth from that star is inversely proportional to the square of the distance. Therefore ratio of the brightness, which is equal to the capital D divided by D whole square. So then equation 1 becomes the difference in magnitude. Instead of their brightness, we are going to write distance. Therefore log A by B, that is equal to log A minus B. Therefore here log DE, D is the 10 parsec. Therefore log 10 is equal to 1, that is 1 parsec. The log 10 is equal to 1. Therefore ultimately the difference in magnitude, m is the apparent magnitude, capital M is the absolute magnitude, that is equal to 5 log D minus 5. If you know the apparent magnitude and the distance of the star from the earth, easily we can find the absolute magnitude of any star. So let me comes to the end at the worksheet. We are trying to answer these questions by knowing the stellar magnitude system or brightness of the stars. The first question, what is the, see a star A has apparent magnitude which is plus 5.4. The star B has the apparent magnitude is plus 2.4. The question is which star is a brighter and how many times? As I said, the higher in magnitude star is a star A, lower in apparent magnitude star B. Therefore star B is the stars having lower in magnitude compared to other star, that is a brighter. Therefore the star B is the brighter. How many times? The difference in these two magnitude, that is equal to 5.4 minus 2.4, almost 3, that is 3 times, that means almost 2.512, 2.512, 2.512, almost equal to the 16 times. The star B is 16 times brighter than the star A. Please try to calculate or solve these questions. Thank you very much.